Welcome to Uplink, where we explore the world of digital infrastructure, uncovering the technology fueling AI and cloud innovation with the leaders making it happen. I'm your host, Michael Reid, and my guest today is Jay Smith, Vice President of Data Center Operations and Engineering at Evocative. Jay's 3 decades in digital infrastructure reveal how data centers keep evolving, from dial-up all the way through to AI. He shares how his team is retrofitting old facilities for new power demands. It's crazy. Let's dive in.
Good morning. How are you?
Yeah, Jay, great to have you. Thank you for coming. Yeah, I've got a lot of questions.
You have a lot of questions?
I do.
Okay.
I've always got a lot of questions. So, well, firstly, you're at Evocative now, but that's not where you started. But you've been playing in this game for, a couple of years now. 29 years. So I think it was 90s that you were saying that you started
Mid-90s. I went to work for my business partner who retired 7 years ago.
Yeah.
When we sold the company to Evocative.
Beautiful. So hang on, you're in the 90s. Internet's sort of just coming into its...
It was still the Wild West when I started, but it sort of...
And was it internet that you're involved with, or was it actually sort of data center or Colo? What was it then?
We pivoted to Colo in 1999.
Wow.
2000.
Okay.
And then before then we sold dial-up and hosting and T1s and DS3s, and then got into the DSL game. And
so you were actually reselling that as a partner?
Mm-hmm.
And then sort of started to build out.
Well, we always wanted to manage the network, right? Customers they need support and assistance. They didn't understand how any of this worked, and that's what we were for. And
so this was like, what was that? DSL, dial-up sort of era?
Well, we pivoted dial-up to DSL to...
And business or consumer?
Both, really.
Okay.
But again, we pivoted away in 99, 2000 to the Colo world.
Okay. 99, 2000 Colo world.
Yeah.
Everything's exploding. It's about to crash.
And then it popped.
You survived.
We survived.
That's
and then
pretty impressive.
On the, the funny part is we built our first data center at 600 West 7th Street, downtown LA. I was buying gray market cabinets from level 3, and I had like a bunch of network gear that we got, from, like, I had patch panels, I think, in the data center today that still say Enron on them. I mean,
wow. Yeah.
I've been around a while. I'm a dinosaur. So
well, I mean, back then data centers have changed. I mean, they've changed and they haven't changed.
They keep changing.
Who's landing them? What were you trying to do? Was it more carrier related or?
No, it was more, I mean, back then we went to that site, right? The carrier hotel. We went there because, for the cost of a cross connect at the time, it was cheaper to just be in the same building with all the carriers.
Just connect straight in, yeah.
And
which was it is changed, but that's been this sort of key. It was super key, all that interconnect. Yeah. All that fiber coming in, all the carriers, that became sort of these, I think the founding part of many data center companies, actually.
Yeah.
Yeah.
Everybody wanted to be where the carriers were close, right?
Mm-hmm.
So, customers would buy a cabinet or a cage, and we grew there to almost 2 megawatts.
Back then
it's
huge.
And then we sort of shrank a little bit. And then I want to say the peak there was probably 2012, 2013.
Got it. Yeah.
And then
what was happening then?
The cloud. AWS was born.
Yep, that changed everything.
It did.
Yes.
And
okay, you're at that period, you're a data center company. And the cloud comes along, and everyone tells you that.
And you're going out of business.
You're out,
right?
Yeah.
Well, I'm still
so
here.
Funny? Yeah, exactly.
Right.
Well, it's so hot right now, and isn't it funny to go back into that time?
This business has been cyclical for forever, right? It was hosting, and then I want Colo and my own equipment, and then it went to AWS.
Yeah. But are you also doing some hyperscale as well, or is that just
on the smaller side, right?
Yeah.
Hyperscalers don't come to us for 48 megawatts, right? We have a network pop and we need, a couple megawatts here and there.
But you're also seeing sort of these neo clouds, all sorts of, I mean, there's so many pieces of the puzzle that you solve for. But before we jump into that, you ended up, I guess that company then
was acquired by Evocative in 2018.
Okay, but you didn't just sail off into the sunset.
My business partner retired.
He sailed off into the sunset.
He sailed off in the sunset.
Okay.
I didn't know what to do.
You can always leverage his boat. That's important because you don't have to pay for the repairs.
Yeah, exactly.
Yeah. So you stayed.
I stayed, and I said I'll give it 6 months.
See,
I'm here 7 years later,
Okay.
and
And you're building, you're growing.
we've done some acquisitions, and we're building today. We're adding in our facilities in Secaucus and Plano.
Yes.
Early stages in facilities in Atlanta and Redondo.
So give us the high level. How many DCs you got? US
15
based?
U.S.
Yeah.
based.
Any thinking of going outside of the US, staying here?
Exploratory. It's still early.
Yeah. I don't know if you need to. I think there's so much opportunity here still.
I mean,
You could.
majority of the data centers in the United States anyway.
Correct. Plus, it's hot. And actually I think a lot of maybe even more pullback with the sort of geopolitical landscape that's going on. I think there's probably more opportunity at the moment. It's changing fast. I don't know.
Well, and again, I think we're just starting to scratch the surface, right? Like it's everybody's training, everybody's building to train. And, once they're trained, what happens on inference?
Yes, edge. Yeah.
And we're going to push to the edge, and then it's going to be, I need, 30 to 100 kilowatts of rack, but I only need 2 racks.
Yeah.
And I don't really know.
Yeah.
I'm sorry?
It changes what people are going to need or what companies are going to
They're going to want to push that to the edge.
Yes. And that's a latency thing.
Yeah. They want to, everyone on their phones wants to click and get the inference quickly. And that game is, so we talked about carrier hotel.
Yeah.
It's different now. Your service SDN pushes the edge to any data center you're at. You don't necessarily need to be in a carrier hotel anymore.
Well, it's kind of one of the things I was just thinking. Our value prop is that we provide that capability from any data center that we land in. Yeah, and connecting you anywhere now. So that does change that sort of carrier hotel mentality.
And when I think the training's done, I think we're going to see another explosion of connectivity that's just, everybody's, over the last 10 years has been buying gig and then 10 gig, and now, everyone wants 40 gig or 100 gig, and well, it's going to be
next
4, 8, and I don't even know what's after 8.
Well, we're even trying to procure 800. We've got, our backplanes are all 400 gigs, so we can deliver 100 gig in 60 seconds. And we've been, just on this note, we've been asking for 800. We wanted to be one of the first in the world to roll out 800 gig backbone so we can deliver 400 gig. We're struggling to find people that can deliver that. We might even cross to 16, 1.6 tera, before we get to 800.
You would have asked me 20 years ago, we're going to push 1.6 terabits down a pair of fibers. I would say, you're crazy. And here we are, like every day, it seems to keep, it's just going to keep doubling.
Well, what's weird is when we roll out 100 gigs and we punch them out quickly from your DCs, people fill them. That's the weird part. Because you can talk about speed all you like, and it's until it's been consumed. It's only when you know it's been consumed that someone's doing something with it. It's like all these AI folks. A lot of them sort of came on early, and we didn't see much happen. But now we're starting to see all this consumption come through. And maybe that's the rollout of inference potentially. Or
it started. Like, I figured it would be another year or two before we got there.
Yeah.
The workloads are getting trained way faster. So it's a matter of, and it's everything from your personal assistant bot to
image gen, video generation.
I'm gonna plug my daughter, who's a graphic artist, right? And she said, "Dad, I'm not gonna be out of a job. AI is gonna put me out of a job." And I'm like, "No, somebody has to teach AI how to do it, and has to babysit it, because AI."
It's a little bit, random. It's got some hallucinations.
But again, and so she's dove into that too.
Yeah. Well, that's the key. If she can leverage the platform to make, and that's what we've found, content's been created so much quicker. But if I try to create content, it's terrible.
Right.
I'm trying to tell the model whatever. But it's been able to use these, tell it what you want in a way that it needs. So it gets coding for the AI, I suppose. It's the new hot thing. That's just communication to it. Yeah. And I think she's going to be fine.
And again, it's not that you have to tell it what to do. You kind of have to coach it along.
Yeah,
right?
It's coaching.
Right. I'm an AI coach. Well, what does that mean? Maybe it's a new job. Who knows?
That is the new job. Yeah.
So, again, everybody's after all this capacity, and everybody talks about there's not enough power in the United States.
Yeah.
There's not enough, the grid can't support it. So now it's, maybe I'll do gas generation or
Heard some things
natural
with
gas,
nuclear
blue.
even coming in discussion.
Yeah, well,
Gas is quicker, I guess, in terms of what they can roll out.
it is. I mean,
There's the other piece is not just generation, but distribution is certainly an issue.
but if you can do generation on site,
Yeah.
then your distribution is
Are you guys thinking about that, or is that just something you explore? Like everyone's
I've
looking.
started digging into it.
Yeah.
Some of the byproducts which are beneficial are that when you do generation, you can use. It also produces chilled water, so you can leverage that for these high-end cooling capacities you need.
Yeah. So you're getting people turning up, trying to, I guess, liquid cooling. Is that something that you're getting asked for? And
Yes.
the amount of kilowatts per rack has just gone up.
And part of it is you got to take an existing data center and retrofit it.
That's
How
the
do you
tricky
do
part.
that?
Yeah.
In a perfect
Dealing
world,
with water, liquid.
either medium, right? You
Yeah.
can use DX. The cooling suppliers are rolling out new products every day.
Yeah.
And it's
Moving
again,
quick, I guess. Yeah.
I mean, in the perfect world, you have a chiller plant, you do a CDU, liquid to the rack, whether you do RDHX or.
And what are are they chilling that right down to, or is it just like room temperature and that's enough to cool it? What is?
So we have the one of the nodes we have running today it's in a 20-year-old data center.
Yeah.
Right? We're supplying 64-degree air on the cold aisle. The AI servers are grabbing that air, pushing it out the back north of 100 degrees
Yeah.
into a root or heat exchanger. And that root or heat exchanger is grabbing it basically at the source and spitting out 68-degree air. So you're going from 64 to 68. So now you only have to cool 68 with traditional cooling.
Interesting. So what's that? That's like a chiller unit on the back that chills
It's a
it.
door that's basically a crack unit or a crate unit.
Yeah.
It's intense.
And so you were able to basically retrofit the data centers that you've had, the older data centers, I guess the ones that have been around, to make them purpose fit for today's requirements. So you don't have to.
At the smaller scale, you can't do it at scale.
Massive,
right?
yeah.
Yeah.
Now, it's the other one. So we're seeing other data center providers that have just pivoted to focus solely on sort of hyperscale. But what I think that's pushing down is this opportunity for Colo, because they're pushing Colo out of. Some of them are saying, we don't want to supply Colo, we just want one big facility. But now, then, from what I can see, is Colo's sort of rising.
That's supply and demand, right?
Yeah.
It's simple economics.
Yeah.
So when there's less supply, the costs go up, prices go up, and there's still traditional colo. Like people look for small footprints all the time.
Yes.
Rack, 2 racks, 5 racks. And even originally AI push was, we need 5 megawatts. Well, now we're starting to see, no, we need 100 kilowatts. We only need 8 racks. So, and that's a traditional NVIDIA configuration of 8 to 10 racks with 1 storage, 1 network, 6 to 8 racks for AI.
All right. And so how many DCs do you guys have now?
15.
15. And regions, how are you thinking about, is there a mixture of acquisitions, or how have you thought about the strategy of where they're landing, where you're building, where you're investing, et cetera, et cetera?
So again, it's about, near term, where do we have available power from the utility?
Okay. Goes back to, what can you get?
What can I get? Where can I get it?
And can you build more in some of the facilities, or are they sort of can't add more to that system?
Plano, Texas, prime example.
Yeah.
We're in construction in Secaucus and in Plano today.
Cool.
And
that's an extension or a new DC?
We're just tagging. We have an empty hall, right?
Got it.
Technically a warehouse today.
Yes.
We can get small chunks of power in Secaucus.
Okay.
So it'll be effectively a couple megawatt add. Turn around to Texas, and they say, you can have 24 megawatts utility in 12 months. So eight times what we can deliver in Secaucus, we can deliver in Plano.
And so you'll build there?
Yeah.
Yep. And that's is it a warehouse style facility?
Same drill.
And you extend the warehouse more, or just inside the warehouse?
We have built effectively data hall.
Yeah.
That we can expand into.
And that'll come online
May of next year.
Beautiful. Have you sold it all already?
And it's still available now.
All right. Yeah, we got some.
Yeah, it might change in a week.
Yeah. That's what we're also finding.
Yeah, it's purpose built. So, we're building and planning these new halls to be liquid to the rack ready.
Right.
And then you can go RDHX, or you can go with
what's RDHX for the view?
Root door heat exchangers.
Yeah. Okay.
So put the magic door on the back of the rack, and you're cooling from 70 kilowatts down to.
What is that? It's just like a big fridge, like a radiator on a car.
It's a radiator on a door.
Yeah.
It's a radiator on a door with
you're running cold water into, or some cold liquid or something into that.
Cold
thing,
water.
It's just coming through, comes out, and then you're grabbing that and just recycling it back through.
There you go. Just close the loop.
Yeah. That's interesting. So that's different to what has been done in the past. Most of it was all air. Like stair cool just came through, as opposed to then having this cooler unit in there, or is that not the case?
Again, you do in a big box format, right?
Yeah.
You you surround the edges with all these HVAC units, and you're traditionally blowing cold air onto the floor, putting the cold tiles where you want, and distributes it in where you want the cold air to go.
And then it sucks it out.
And then heat, hot air rises, cold air falls.
Yeah.
Hot air goes to the ceiling to return air plenum. HVAC grabs that air, typically a 20 to 25 degree delta T between what it grabs it in at and what it spits it out.
Yeah. So now you're delivering, and also you're saying, when you say cooling that's to the chip, is that like where you're running liquid and
you're running, so the racks will have generally stainless steel chilled water to them.
Okay. Every rack you can tap into it.
You tap into it
like you would plug into power. You're now plugging into a water source at these locations.
You try to want to keep them apart as much as you can, right?
Yeah.
But again, the connectors are. The technology on the connectors is just insane. Like you literally unplug the connector on the chill water loop and.
Well, I know it's been around for a while, but it has never been around at scale like this. So there's
I look
so
at it
much
like this
change.
way, like gaming to me. That was the big push into cloud in the beginning, in my opinion. Right? Everybody wanted their own game server to run.
Yeah.
But I date myself a little bit, but get back to the Counter-Strike 5.2 beta days,
Love
right?
Counter-Strike.
We've all played it.
LAN that at university.
There you go. So I think that was a big push. And then, they were, we got to get more out of these GPUs, right? I got to run it faster because I got to have latency.
Yeah.
And sure enough, they brought liquid to
the chip or whatever,
And I think at that point is when NVIDIA said, whoa, this works. How do we do this in the AI world?
Mm-hmm.
And again, they're talking, some racks are doing 275 kilowatts a cabinet, 600 and something kilowatts a cabinet, megawatt a cabinet. So it's like
megawatt a cabinet. Megawatt data centers.
Yeah.
And now you're getting that in a cabinet. So what people probably need to understand, or maybe it's obvious, but if you're punching a megawatt of power, it means you're creating the heat. And so
it usually takes one and a half. So for every megawatt you consume, you're consuming a megawatt and a half of utility power or generator power.
So 0.5 basically to cool it,
right,
is what you're saying. Yeah. Got it. Yeah, fascinating. Yes. And that's, so you punch that into one rack. There is no choice but to cool it via some sort of liquid.
Yeah, you have to do liquid.
You melt a hole on the floor.
Yeah.
It's pretty mind-boggling. But that's what's changed so quickly.
Like that's 3 years ago, you have this conversation, you say you're crazy.
Yeah. But that's a big change. That's a big change because it's such a we change a lot in technology and software. But what's changed is the physical build, like actual physically having to run liquid to these locations, the connectors that you're plugging in, ensure that those things don't leak, don't have an issue. It's obviously running some incredibly expensive tech.
Yeah.
How you do that on scale? How do you choose the right
four of those chassis? You put 4 of those chassis in the cabinet that's north of $1 million a rack.
That's crazy.
Just in servers. You're not even talking switchgear. You're not talking storage.
It's $1 million a rack. How many racks you got in there?
It's a lot. Again, let's say a standard footprint is going to be 10 racks.
Yeah.
That's, $10-15 million in their gear alone.
Plus the cooling, plus
Plus
the
the
power.
cooling, plus the power, plus
Yeah.
the build to install it. I mean, he gets to $1 billion pretty fast.
Yeah, I think that's what people probably don't fully appreciate. Now, here's the other thing. A lot of talk about this, we're in a bubble. Oh, we're in a bubble. Everyone keeps carrying on about it. I've heard, I'm actually hearing less of that now. I'm hearing that it's actually more of this is just the way it's going to be ongoing. A little bit, not that long ago, we heard bubble. Then we had this like little freak out moment when was the Chinese brought out that, which model did they bring out that scared everyone?
Yeah, again, I don't even remember which one it is.
Yeah, exactly. Yeah, Deep Sea came out or something.
Yeah.
And I was like, we don't need to try anything, and then a chain came back. But I'm hearing that it's getting bigger. Like when I just heard the Grok, so GROK Grok, Elon's one. I think he figured out how to get 100,000 GPUs, and that was this crazy thing 3 months ago. Someone said he's at 300,000, and then someone said he's trying to get to 1 million of GPUs just on training. It's like everything's getting bigger,
their
bigger,
build
bigger and more.
and their build that they did in Memphis.
It's insane.
Well, they didn't bother with utility power.
Yeah,
Again,
the
natural
diesel
gas
gens.
generation.
Yeah. Was it gas generation? Was it? Yeah.
Natural gas generation, and they were able to do it at scale and rapidly. And again, the byproduct is you get some cooling out of burning the turbines.
Yeah.
So that's okay. Do you bother with generators at that point? Diesels,
Yeah.
right? Do you just go with natural gas and make them redundant in that configuration?
Yeah.
I've kind of explored that a little bit.
Interesting.
So rather than having the traditional Colo build with utility feed, with generator backup and a UPS, just go natural gas generation
Okay.
with a UPS.
What do you need license-wise to do that, or it's something you can just get approval? It's from a build or something.
Every market's going to be different, right? I mean,
so then it's just gas prices that you got to worry about.
Interesting. You buy RECs to offset that as well, but
Yeah. of
again,
course.
these are very, very early stage.
Yeah, well, this is to solve the problem. The problem is like we don't have enough power. So how do you solve that?
Yeah.
One thing you can always guarantee, if there's a way to solve it, a capitalistic mindset is to go and solve these problems. And if it's not government driving it and it falls into the capital markets will solve it if they need it. And
Yeah.
we're seeing that come. That's interesting on the gas gen. Didn't think about that. You don't need. Everyone's like running low on diesel.
Well, and diesel is, I'm closer to retirement at college, right? So I'm to the point where it's like, I want to leave the world better than I found it, right? We don't need AI to turn into this matrix,
Monstrosity.
right?
Yeah.
When it takes over, or if it takes over, and I don't think it can take over. It would be funny.
Skynet.
We have staff running around. They say Skynet is my friend. They have T-shirts and they wear them.
Yeah.
It's just don't get at the nuclear code. So I guess this is the way to avoid that.
Put it down on a piece of paper, the nuclear code, so it can't read it.
Yeah.
Yeah. So what else is going on in the evocative world?
We're just, again, Colo's cool again.
Yeah,
right?
it is cool.
I think they need the traditional.
You say so when you say Colo is cool, are you seeing companies just expand more? Are they repatriatizing? Are they mixing what they put in cloud? And
I think the new phase or the new mode is you have to do hybrid, right? There are tons of things, tons of workloads that make total sense to run in the cloud, right?
Yes.
And there are some things that makes more sense to run in gear that you support, and a lot of.
And so you're seeing customers make those choices deliberately. In the past, it was sort of like we're migrating to the cloud, whatever's left we're keeping because we couldn't get it to the cloud, or we didn't get there, or we didn't get to the cloud in the first place at all. Now you're seeing deliberate choice to say, all right, putting a whole heap of this in the cloud. And by the way, this is it's the pie is just increasing for everyone. It's not like one loses whichever way this goes.
Right.
Everyone wins. But it's more like what those decisions are. So you seem like workload specific come to you and say like we're building this here and that there.
Yeah, a couple of years ago we got some statistics that said 47% of CFOs that were interviewed, their spend was 20 to 25% higher in AWS and Microsoft and Google than they originally budgeted.
But the question is it that they expanded 25% more, or they just didn't budget enough, or is it more expensive than what they...
I think it's a combination of all of those things, right?
Exactly.
You're going to have your, zombie compute instances that somebody spun up because they had the login, right?
Yeah.
And it just sits there spinning, and nobody's using it. You have,
out there.
egress, right? Egress is expensive. It's free. And, you can offset some of those things by whether you're leveraging an on-ramp, if you would, either way, and pulling it back, or, hey, maybe we just build a stack. And again, it's back to, do you want OpEx or CapEx spend, right?
Yeah.
Like those are real.
Yeah.
And again, everybody pivots from one to the other, depending upon, oh, no, we got to spend more on CapEx.
We're now in CapEx, now we're in OpEx.
Yeah.
Now. It's changed all the time. All right, so crystal ball, looking forward, you've been in this game since the 90s, so you've seen it all. I don't know, what's the next, what comes in the future? 5 years out, 10 years out? Probably too far to think 10 years out. I can barely
I think it's more
3 months out.
10 years out, I'm thinking, we're taking my dog to the park every day. Playing my tulips. No, I mean, I think if you would have told me 3 years ago, I don't want to think 5 years, I want to think 3 years.
Yeah.
If you told me 3 years ago we're going to go liquid to the rack and liquid to the chip, and I would have said you're crazy.
Really?
That a year later, I'm like, no, this is coming.
Standard now. Well, you got to have it.
Yeah. Again, demand is there.
Yeah.
So, and again, back to, all these workloads are getting trained, and inference is going to be humongous.
Yes.
And
well, I saw a demo of inference. I mean, if we went and saw it at the Grok Labs and GROQ, not GROK, and just the speed at which you're getting full responses, it's pretty much instantaneous. Like, it's milliseconds versus you are noticeably maybe 10-second responses in the past. These things are delivering at milliseconds.
Well, again, where are you seeing it? You're seeing it on site in their lab with
very close
connectivity, low latency.
Correct. Yes.
And if you're running inference and I'm in New York City and I pull out my phone, and again, that's the other part that I think everyone doesn't realize is everybody's gonna go to inference off their phones.
Yes.
It's gonna.
Of course.
We all do searches like, somebody brings up a movie at dinner and somebody pulls out their phone and then you have all the data.
Yes.
Well, when somebody wants, to ask the AI, well, what about this? Or what about this? Or give me the data on this. And they're in New York City and the inference is pulling from the West Coast.
Yeah. Big delay.
Add 50 milliseconds.
Yeah. Plus it's got to process and the time and. Yeah.
As opposed to, well, let's build all of our instances all over.
Which is a bit like networks, actually. You were always trying to design a network so that you weren't tromboning from one side to the other. You're trying to get the content as close as possible. CDNs is a great example. It's almost inference becomes like the content distribution networks. It's like of old becomes maybe the new inference at the edge as it changes. That's changing super fast, and there's some really interesting players sort of jumping into this space. NVIDIA's changing, but there's other chip providers that are appearing that are just purpose-built for that. Also, a lot of the hyperscalers are building their own chips. So it's all happening at the same moment.
And again, it's all going to be slightly different than everything else. Like
yes.
It's flow rate on chilled water and what temperature do you want it at. And
these are the specs that they're asking.
And
flow
again,
rate on chilled water, like how fast can you pump water into it is now like a
flow rate.
Yeah, that's the new
flow rate and temperature and filtration. Like, interesting.
Yeah.
Do you want water that's only been filtered to 25 microns, rolling down and settling, and then have some chunk of sediment settles on a chip?
Wow.
Right. And again, that's a $300,000 box.
Yes.
That's something to think about.
Yeah.
And
is it oil as well, or is it water? What's
water? And it's not necessarily oil. I mean, submersive is a route you can go, but
We're seeing it not go that route. You're seeing this,
I'm seeing
and
it
it's
the other
mainly
way.
it's water. Yeah,
It again, water generally, but again, there's you're going to treat it with some type of chemical,
Yeah,
like glycol or what have you, right?
Yeah.
But you know, having filtration that's 10 microns,
yeah.
making sure that it's about as pure as it can be, or desalinated water, right? So
It doesn't create any scale or whatever it is,
and you don't have anything that builds up, and it doesn't conduct electrons.
Interesting. Yeah.
So it's, again, we're just starting to, I think we're really starting to just scratch the surface on how crazy it's going to get. Because how long before everyone catches up with NVIDIA? I don't, is it a year? Is it 3 years?
Those guys move so fast too. Yeah, the tech they're coming out with and the iterations are just insane. It's amazing. All right, so one last piece. Advice for folks looking to get into the industry. Is it a good industry to land in? It's pretty hot at the moment.
Absolutely.
Keeps
Whether you go to
changing.
college or not, doesn't matter.
That's a good point.
Think about this. So every data center has got to have security. It's got to have technicians. It's got to have facilities engineers, right? And I call myself a dinosaur, right? But I'm not the only one, right? We're all closer to retirement than college, and there's a huge opportunity for students right out of high school to go to trade schools and colleges.
That's an interesting point. Like, you think of being at high school and you go, I got a choice. I go to college, or I do maybe like a trade.
Right.
I might do like a plumber, an electrician, a carpenter, whatever. There's a space here as well that you don't need to go to university or college. You could go and actually become
Electrician,
Yeah.
HVAC technician.
Yeah.
Right.
Yeah.
We need welders. We need, there are, if you think about it, for every data center that gets built, there's construction. And you have to have all of these specialized trades.
Yeah.
And even to the technicians that have to do the, customer opens a ticket or support.
When you're replacing a chip, or you need to get something sent out there, remote hands.
And now we're going and turning it on its head and saying, oh, by the way, this server is also liquid based. So
on top of,
you have to
And you're
understand and
certified
train
or
it.
whatever.
Yeah. And again, I need to upgrade RAM in that machine. Or,
AI is not doing that.
I'm sorry?
AI is not going to install your chip.
No.
Yeah.
AI needs humans.
Yeah, thankfully.
So it's
a great career path, in short.
Yeah, and again, you go the college route, you can learn.
Yeah.
Even I think there are enough trade programs now, even on the networking side, right? Where like a lot of us that are in the industry didn't finish college. And I mean, I was learning more in the office every day.
Yeah, on the job.
On the job.
Figuring
what they were
out.
teaching me at university was
it's probably
10 years prior. I mean,
token ring or something. I don't know. Who knows?
AS400s. And that's the funniest part. Like, that's AS400s at the time were cooled. So they want to talk about cycles, right? And everything goes back to the way it is. Then here we go, right? It's just, I mean, there's more computing power in your phone than there is on an AS400.
That's great. Yeah.
And that's the other wrinkle. Like, could you program inference on a phone?
Yeah, that's the next piece. Can you get a chip that's
Can you
punching
get a
out
chip
inference on there?
on your phone that can do the inference for you? And how is it trained? How big is...
Can you stick a model on it? Can you keep updating the models? Maybe. Yeah. Maybe Apple becomes the inference.
Who knows?
Yeah.
Right? I mean, these are crazy ideas that, 20 years ago, I would have said you're nuts.
Apple.
Well, liquid-cooled, smartphone.
Yeah.
Like, that's probably very unlikely, but...
It's funny.
Anyway.
Yeah. Cool. Well, I appreciate you, A, the partnership, B, coming on the show. Really interesting times. I mean, the last 2 years sounds like it's changed.
I don't think it's done changing.
Yeah.
I think it's just going to keep, again...
But it does feel like it's changed faster in the last 3 years than it maybe did in the previous 10, but maybe
yes.
not. I don't know. Yeah.
Things were crazy. I would say, going back to 2011, 2012, things were crazy.
Yeah.
And then the push was to go to the cloud.
Okay, now everyone's cool to be in DC. I'm sorry? It's